Nice. We are live, I think.
Login accepted.
I love that, but that is entirely too intense for what we're going to be talking about this morning. First of all, thank you to everybody who woke up to be here this early. I applaud you. I appreciate it. This is the Kafka and Plant Talk, for those of you coming in to join us. And I am obligated by my colleague's daughter to display this tiny plushy plant here. So please enjoy. His name is Jimmy. All right, let's get to it. My name is Danica Fine. I am a developer advocate at Confluent. And so what does that mean? I'm a Kafka person. I love Kafka. We can go on and on and on about that if you have more questions about that technology later. But the only other thing you need to know about me as a human, because I absolutely accept Kafka as being part of my my identity as a human, the only other thing you need to know about me is that I really like houseplants. And so how many of you have houseplants? Great. See, I love that it resonates with humans. That's so good. So these are some of my houseplants, just a small subset of them. Gosh, everybody's showing up now. Small subset of them. I have like 30 or 40 plants in my house. That's entirely too many, especially when I lived in a smaller apartment. It's absurd. I now have a little bit more space, but this kind of got out of hand over the pandemic, right? That's what I did. There was nothing else to do in life, so you buy a bunch of plants and hope that they live, and it makes you happy, right? And for the record, I like when my houseplants look like this, and it takes a lot of effort to keep them looking like this. For those of you who raised your hand and said you have plants, you know how much effort it takes. Sometimes you have some easy plants, but then you get that problem plant that needs like a lot of attention, all of your attention. And so to keep my plants looking like this, I do multiple rounds per day, especially over the pandemic, right? When I had nothing else to do. You check on the plants a lot. And so they were fine. But as I started going back out into the world and living my life and not being at home the entire day, I ended up getting plants like this. This is a sad plant. I don't know if you can tell from the back. They're not supposed to look like this. This is a very wilted, very pathetic plant. And so this day, I forgot to check on my plants in the morning. I went to the office and I came home and I was faced with this. And I felt like a really awful plant parent. I don't want to feel that way, right? So this is neglect. That's what it is. So I didn't want to have this happen anymore, right? I needed something to remind me to take care of my plants, and only when they actually needed to be cared for. So I asked myself, is there a better way? Of course there's a better way, right? I can go on Amazon right now and probably buy some sort of system to help me monitor my plants. That's a very easy thing that you can go out and purchase. But that wouldn't make a good story. I wouldn't be here today if I just went on Amazon. So that's the wrong question to be asking. Many of you are engineers, you're analytical people, you're at least a curious or creative person. You're at this session at 9 a.m. Thank you. So you know better than to ask that question, right? This is the right one. Is there a more interesting way for me to be monitoring my houseplants to help me take care of them? And so I am a Kafka person. I spent a number of years in industry working with Kafka, building out streaming data pipelines. And so when I became a developer advocate, my one promise to myself was, I want to build projects that are actually useful, not just a toy thing that looks cool or sounds cool. I want to build something that's actually going to solve a problem in my life or solve a problem in someone else's life. And so this is a problem I had. I had a lot of tools in my toolbox, namely Kafka. And I also really wanted an excuse to build out a hardware project for the first time. So this is like the perfect storm. Watch out, because I love talking about this. Perfect storm of being able to use Kafka as the backbone of the system to build a system that would help me monitor and take care of my plants. And I can get a Raspberry Pi out of it too. So let's talk design. So this is what I envisioned, right? I just wanted a system to help me monitor the plants. I didn't need it to water them necessarily. I was renting at the time, so I don't need a lot of like reservoirs and pipes everywhere. And so all I wanted was something to tell me exactly when I needed to take care of my plants, and not a moment sooner, okay? So what I envisioned was I'd have some soil moisture sensors in my plants. I'd capture those readings regularly. I'd throw them into Kafka, because that's going to be the backbone of this system. But those readings wouldn't be good enough on their own. I'd need a little bit of metadata, and I'm going to do some hand waving here because we'll find out what that is. And I'll throw that data into Kafka as well. From there, we'll do some stream processing, actually determine if those plants need to be watered from that information. And I'm a lazy person, or that is true, I am lazy. But really, I just wanted it to be convenient. I wanted to receive this data on my phone. Okay, and I like using Telegram, so we'll get into that and how I got that data out of Kafka. Okay, so Kafka is a really big part of this project, right? It's in the middle. It's the biggest part. So I want to make sure everybody knows, we level set, right? We understand what this technology is. So I'm going to phrase this both ways, so get your hands ready. How many of you work with Kafka currently? Okay, how many of you, this is your first time working with, hearing about Kafka? Okay. Some of you. Okay, good mix. I like that. We're going to get a refresher for those of you who actually know what this technology is. Kafka is a distributed event streaming platform. Okay, simple, right? We're done. That's a pretty short description, but there's a lot to unpack in each of those words, so we're going to break it down very quickly here. It is a streaming platform. And every time I forget to say this, it comes up inevitably. It is streaming, not like Netflix, streaming as in how we work with our data. So we've been undergoing a paradigm shift in how we work with our data, how we process it, how we store it, how we move it. And this has been happening over the last decade for sure, a little longer. But we're moving away from batch-focused systems, right? We're moving away from capturing this data, aggregating it over minutes, hours, days, and then processing over it, and we're going to stream processing. Okay, we're building systems that are going to react to maybe smaller amounts of data more regularly, more frequently, and we're producing actionable results more quickly, ideally in real time, right, as close to when that data is created as possible. So this move to stream processing, there's a lot of technologies that can help you do this, not just Kafka. Kafka's just one. And generally, there's a lot of benefits to it, right? You're going to be able to increase the accuracy of your data and your results. You're going to be building a more reactive system, right, a more event-driven system. And in the case of Kafka especially, you can actually increase the resilience, the fault tolerance of your system, and you're going to be building a loosely coupled system as well. Those all sound like good things, okay? So Kafka is a streaming platform, but more than that, it can also serve as a messaging layer, just if you want pub/sub. It can serve as a persistent storage layer. Is Kafka a database? I'll let you think about that. And it has a lot of tools built on top for stream processing, as we'll get into. But more than that, it is an event platform. Okay, and what are events? I feel like we kind of all understand what events are, but we don't really think about them enough. So in order to use Kafka successfully, if this is your first time hearing about Kafka, this is the one thing that you need to take away. All right, to use Kafka successfully, you need to think in events. And that's not me asking you to rewire your brain, I promise. This isn't a big ask, because you already know how to think in events. As users, as programmers, as humans, this is a very natural way for you to reason about the world and interact with the world. Okay. Every time you submit a form online, every time you look at application log files to debug, and I hope you do, every time you get a notification on your phone, all of those things are events. And you already know what to do with them, right? You know how to respond to them. So I'm just asking you to be a little more conscious of this fact, okay? So those are all examples of events, but what is an event actually? Events are one of those things that you kind of know what it is, but you don't really define it usually. So an event is just a piece of information, usually a smaller piece of information. We want it to keep it simple. And it just describes something that's happened. That's it. It's that easy, okay? Just keep that in your mind. So what do you need to know to describe something that's happened? Well, you need a timestamp. That's a big deal. You need to know when that thing occurred. You need to know who or what was involved, the subject of this event, and then any other supporting details that might be required there. So in the context of this system, we're monitoring these plants. We're taking soil moisture readings. So I could say yesterday at 2:30 p.m., this plant here had a soil moisture reading of 19%, which is low. That's a sad plant. Okay, that's a dry plant. So breaking that down, we have the timestamp, right? Yesterday at 2:30 p.m. We have the subject, which is this plant right here, and the supporting detail, which is that moisture reading of 19%. Okay, we have all those critical components to make an event. Another key component of events is that they're meant to be immutable. I'm going to let that settle in with you, okay? I want you to accept that. If immutability isn't something that you enjoy, I'm so sorry. Just get over it. This is not me being a difficult person. This is just due to the fact that events describe things that have already happened in the past. They occurred, and we're recording it, okay? So we don't have time machines. I can't go back. This plant had a very, very sad moisture reading, but I can't go back and change that. It happened at 2:30 yesterday. We took that reading. Now, if I can't really undo that, but what I could do is I could water the plant now, right? And then in a few seconds, we'll take another reading, and we'll generate a new reading, and that one will be better. Maybe it says 70% moisture level, and that's great. But it doesn't negate the fact that yesterday we had a low moisture reading. So by watering the plant and taking more readings, we're just appending those readings to this timeline that describes this particular entity over time, okay? And that's what you're doing whenever you work with Kafka, when you work with events in Kafka. You're just building up timelines that describe entities, okay? So based on what you learned, just about how Kafka facilitates streaming, moving your data quickly and efficiently, helping you to process on top of that, and the fact that we're using immutable facts, that's pretty powerful. If you've worked with immutable data, maybe you understand the benefits of that, namely that, no one can change it. The integrity of that data is protected. It's also really easy to replicate that data over because we know it's not going to be changed. And so when we're working in the context of a streaming system, what this means is that a lot of downstream systems can use that information. We ensure that the integrity is still protected, and they can all build different sort of applications on top of that information. Okay, so that's what Kafka really allows you to do. So how does it do this? Well, we got to look a little bit into the architecture of Kafka, and it is a distributed system, for better or for worse. The primary unit of storage in Kafka is a Kafka topic, and it's just a data set, right, consisting of these events. You get data into Kafka, you write it as key value pairs using a client called a producer. You can have as many of these as you want, writing to as many Kafka topics as you want. From there, we use clients called consumers to read that data back out. And again, you can have as many of these as you want, reading from as many Kafka topics as you want. A couple cool things about consumers. The first thing is that as they're reading through that timeline of events, it's probably useful that they know where they've left off, right? If that consumer application goes down for any reason, we want to be able to efficiently pick back up and start processing. And so they keep track of their spot using a bookmark called an offset. All right, every consumer has the ability to keep track of this. Consumers can work together as something called a consumer group. And so they're able to parallelize the processing of events from a set of topics. But they can also work completely independently. And that might not sound like a really, really cool thing, but in Kafka it is a really cool thing, okay? These consumers are able to read the exact same information from the same set of topics independently, not impacting any other consumers as they're doing that, okay? And that is so important, right? If this is your first time learning about Kafka, it's very easy to compare Kafka to a similar technology like messaging queues, right? But a Kafka topic is not a queue. It is not. It is a log. It is a commit log. And so similar to application log files that you use to debug, what happens as you're reading through a log file? Nothing. That data is there, right? It is durably stored in that log file until that log file rolls, which is very similar to Kafka, right? It is there. And while that data is there, any consumer, any person, any of your colleagues can come along and read that exact same information and build up that exact same state of that application in their minds. Right? It's the same with the Kafka consumers, okay? They're not impacting one another. They're able to get that same information if they want. All right, so keep that in mind. These consumers, completely decoupled from the producers, they don't care about each other. They don't know about each other. They never will, okay? Producers don't care who's reading the data that they're writing. Consumers don't care where that data came from. And if a producer goes down for some reason, none of the consumers are going to be impacted, and vice versa. These topics are actually further broken down into smaller components called partitions. We see an example of that over on the right. And these are where the individual events, the immutable events, are actually stored. And these partitions are actually the commit logs, the append-only logs where we put these events, okay? And Kafka is a distributed system, so we're going to take these partitions and we're going to distribute it across the Kafka cluster. And what this is going to do is this is going to enable us to use replication for better fault tolerance and high availability of that data. I'm not going to go into those details now, just for so we can get through this a little bit more quickly, but if you have more questions about that, I'm happy to answer it. All right, so that's Kafka in a nutshell. So let's get back to me and this project and this cool thing that we're building. So how did we make this come together? So this is the goal. This is what I want to get to at a point. So step one, Kafka cluster, right? We need one. And this is my first hardware project, and I'm lazy. Okay, I wanted to focus all of my attention on actually building the physical system, and I didn't want to manage anything on my own, right? Who wants to manage infrastructure? Like, I don't know, 10 of you maybe. So anyway, so to make it easy for myself, I work for Confluent, and I decided to use fully managed cloud-based Kafka. So this is just one of your options. You're free to run your Kafka cluster wherever you want. The convenient thing here is that I was able to use other tools on top of Kafka pretty easily. Kafka Connect for moving data in and out of Kafka, ksqlDB, which is in-browser stream processing through Confluent, and schema management. So you can use all these tools regardless of where you're running your Kafka. Just made it a little bit easier in this case. So if you want to build something similar at some point, and I'm going to give you all the tools that you need to build this, just have your cluster running somewhere. I don't care where it is. Get a cluster, step one. Cool. So I have a cluster. Let's get some data. Okay? Let's focus on this system, this Raspberry Pi, the hardware project that we're putting together. This is not a hardware conference. I'll just tell you that right now. I'm not going to explain all of the details, but here is a shopping list if you would like to do this same thing. I did a decent amount of research on the moisture sensors that I picked up. I mean, there's a ton of them out there from a wide variety of price points. These ones were about $1 each. If any of you are hardware people, you will notice that this Raspberry Pi is absolute overkill, but this was back when you could, if you found one, you bought it. Didn't matter which one you found, right? And I think it's still that case. I haven't been able to get another one. Anyway, so a quick note on these capacitive moisture sensors. I know, not a hardware conference, but this is important. This was my first hardware project, okay? I learned a ton. But about these I2C moisture sensors. So I2C components communicate using a unique address, and that is set at the component level, at the sensor level. So all of these sensors are wired up together into the breadboard, and then they communicate over the same wires into the Raspberry Pi. So it's really important that you have that address. You need to know exactly which sensor you're connecting to fetch that data. Okay, so you need that unique address. For a lot of devices, you can just set this. For this particular device, you can only set it to one of 4 values. That's cool. I have like 40 plants, but I can only hook up 4 sensors at a time. I know for those of you who do hardware, you're probably saying, oh, there's hardware ways around that, there's software ways around that. Wonderful. That's beyond the scope of this project. That's in like phase 5 of the project, so keep that in mind. I could only hook up 4 sensors at a time to this project, okay? That's a little bit of hand waving, but you can ask me more questions about it. I built the system, I hooked up the sensors to the Raspberry Pi, and I was ready to actually start collecting this data from my plants. All I had to do was get the data into Kafka. But let's not get ahead of ourselves. We're reasonable humans, okay? I'm not just gonna collect data and just throw it into Kafka for fun. I wanna think about the data that I'm working with. And again, this is me instilling a little bit more of my sage wisdom on you all. Just write a schema, okay? It's a best practice. It doesn't take that much time. And it really, especially in this case, it helped me rein things in because I'm the only stakeholder of this project. It's so easy to just not do things right, right? Because, who's gonna complain? You? Wonderful. So I do like to stay a little bit reasonable whenever I start any project and start with some schemas. Okay, it really helps me think about which fields I need right now, if I can pare some of this back, if I can save some of those for a later edition of the project, and just keep myself honest, okay? So I wrote this Avro schema, and I'm gonna store this in the schema registry. So it's going to be associated with the Kafka topic that I'm going to be rewriting this data to. And this just makes sure that my producers are writing the data we expect and the consumers are receiving the data that we expect, right? So this is a really simple schema. Didn't put that much effort into it. Mostly just the data that we can capture from the sensors, right? The moisture data, that's important, the percentage moisture. We also get temperature for free, which I figured I would also grab at this time just to use for further analysis if I wanted. And the plant ID, right? I'm going to assign all of my plants IDs so that I can keep track of them and use that for joining the data on later on, okay? So this is how the data should look. How do I get this into Kafka? Well, there's 2 main ways. You're going to use a producer or Kafka Connect, okay? The producer API, this is your low-level sort of vanilla way of getting data into Kafka. It is wonderful, it is flexible. What is great is that you pretty much have the ability to write it in whatever language you want. All of your favorite languages and some of your least favorite, it is there for you to use. You'll want to use the producer API if you either own or have access to the application that's generating this data, okay? For example, if I had some website and there was a very specific function that I wanted to log what the inputs of that were and make sure that was in Kafka for some sort of analysis downstream, I'd probably just add a producer right there, a couple lines, and write that data directly to Kafka as that happened, okay? The other option is Kafka Connect. And Kafka Connect, as the name implies, is a way to connect Kafka with external sources and also syncs, as we'll see later on. What's really cool is that it's a low or no-code tool. You just use a configuration to point to your data source, how to authenticate, if it's a database, like which tables you're going to grab, what query you're going to execute against that first, and how to pull and translate that information into events and write it into Kafka. It's really, really convenient, especially when you're, say, like migrating legacy systems. There's always some databases to connect to and integrate. And when you're working with Kafka, it's a best practice to have all of the data in Kafka, right? You want it to be ready right there to start joining. You don't want to make a third-party call to some API to get that data or access the database in the middle of your stream processing. That's just counterintuitive, right? So let's get the data into Kafka. Really, really good, as I said, for getting data from the end of an API, databases especially, and translating that into events, okay? So what did I end up using in my case? Well, I own the Raspberry Pi. I'm the only stakeholder, so we're going to use a producer. That makes sense. And what does that look like? So I'm using the Confluent Kafka Python library for my producers, and I'm specifically using a serializing producer, one that is aware of accessing schema registry and serializing that data accordingly. Some important things, you'll recall that I need to reference each of the sensors individually. Okay, so I put a hard-coded mapping, that should be a red flag, hard-coded mapping of moisture sensors to plant ID. Okay, the sensor address to the plant ID that we're currently monitoring. And then within that script, every 30 seconds, I'm going to loop over that mapping. Okay, I'm going to access that sensor. I'm going to pull that information. I'm going to compute the percentage moisture. And I did have to calibrate all of these sensors ahead of time, computing the percentage moisture, grabbing the temperature, building up the reading object according to the schema. And there's a little bit of extra boilerplate code that I have extracted here, but building up that reading and then serializing it accordingly, sending it to that topic. Okay. This is a pretty straightforward Kafka producer. You're going to do something very similar every time. Okay? And I will have this code linked at the end if you're curious. All right, so that data, that is in Kafka. The readings, we're halfway there, all right? But this data on its own isn't useful, right? I could generalize and say, oh, if the reading is below 20%, great, water the plant, but that's not true. If you have plants, you have needy plants and you have robust plants, okay? And 20% means very different things for those plants. So I need a little bit more information to actually tailor this to the plants, okay, and water them correctly. So I needed a little bit of metadata. And again, it's schema time, okay? This schema took a little bit more effort to put together because I needed to research things. What additional information do I need to understand which plant I'm currently looking at? So we have a plant ID, right? Again, so we can identify which this plant is and join it onto those readings later. We have a bunch of different names for these plants because it's not just the common name. We have the scientific name. We have the given name. They all have names in my house. And then we have the temperature and moisture thresholds that these plants are comfortable within, okay? This, again, a lot of research on my part. There are some databases out there that you can start with, some data sets on, what moisture value are these plants comfortable within. In my house, I live in California. I don't know if that means it's more moist than normal or anyway. Just had to tailor this to the plants. I did a lot of research over a couple of weeks to understand what these plants are comfortable within, okay? So let's get this data into Kafka now. Okay, what are we going to use? Producer API or Kafka Connect? Well, Kafka Connect is really great for metadata. Data sets that live in databases or should live in databases. And this is definitely one of those data sets that should be in a database, maintained there. But again, I'm lazy. I don't want to maintain a database, okay? So I'm still going to use the Producer API, so let me explain. Even though this data set is a slow-changing data set that should live in a database or be maintained in one, I only had 4 plants to maintain at a time. Or at the get-go, I only had 4 plant metadata that I needed to put into this data set due to the sensor hardware limitation. So it was overkill for me to set up a database. And so for now, I just wanted to write this data directly to Kafka. Let's use Kafka as a database in this case, right? Makes it a little bit simpler. And also, I told you I was doing a lot of research at this point in time. So I was updating this data set over time, for a given plant ID. Oh, well, it's not actually that the low moisture level should be 25% for this plant, it should be like 15%. And so we changed that and amend it, okay? So I didn't want to be logging into my computer every time and executing a script to get this data into Kafka. That destroys the whole flow of this project. So I figured, if I'm going to be using my phone to get this data later on, let's also use my phone to produce this data to Kafka. Okay, so let's use Telegram. So how many of you use Telegram? Not enough, okay? I think it's so cool. For those of you who don't, it's like WeChat, WhatsApp, just another one of those messaging tools. But what's cool about Telegram is it has a really rich API around it, and you can develop on top of it. It's kind of fun. So the cool thing is that you can define a bot with Telegram, register a bot. You're given an API key, and then you can write Python scripts to define how you interact with that bot, how a user interacts with it. And so, great, it's just arbitrary Python code. Cool, now I can add a producer to it and capture some data from a conversation and write it to Kafka. All right, so this is what Telegram looks like if you haven't worked with it before. And when you set up a bot, these are the sort of options that you can define, right? You define conversation handlers that users, just myself in this case, can go through to send this data over to go through the conversation with this bot, okay? And so what we're going to do is I'm just going to define how we capture this data in a conversation, collect it, and then ship it off to Kafka at the end. Okay, so for any Telegram bot, you're going to follow the same sort of process. You define this high-level conversation handler that in this case outlines how to capture the plant metadata, okay? And the different states that you're going to go through and what's going to happen at each stage, which function handler you're going to use to capture that information, what you're going to do at each stage, and how you're going to forward it to the next stage. So you're just defining a finite state machine. It's a little tricky at first, but then they all follow the same sort of a process. Okay? So here I'm just outlining that general flow of which pieces of information we're going to be capturing. So the ID, the moisture, the temperature, and at the end, verifying that the information is right. And diving into one of these function handlers, so we have the moisture low command. So I've already asked myself for the low moisture value, and I've responded, right? So I'm capturing that from user input. I'm storing that piece of information temporarily in state for that conversation, the lifetime of this conversation. And then I am prompting for the next piece of information and forwarding it to that next function handler that will then grab that information as well. And we're going to do this for all of them. At the end, after I've decided that the information looks good, we're going to send it off to Kafka. And again, we have that same sort of serializing producer. I've extracted that boilerplate code, but we're doing the same thing. I have a function to take a dictionary of values that I've captured from this conversation, translate it into a houseplant metadata object, and then we have our producer write it to that particular topic. Okay? So cool, now I can write all of this metadata from my phone. When I run this bot, this is the sort of flow that we're going to go through. I say I want to update a plant. I provide the plant ID. I go through capturing all of that information, and at the end, it will produce it into Kafka. Cool. So that's awesome. I've saved a lot of my time. I don't have to store this in a database. I'm using Kafka to handle this information for me, and I don't have to log into my computer to do this, okay? But remember that red flag? I still had a hard-coded mapping of sensor ID to plant ID in my Raspberry Pi collection script. And that's a little unfortunate because now the world is my oyster. I can add so much metadata. I should be able to switch around which plants I'm monitoring at any time. But at this point, even if I add a new piece of plant metadata, I still have to go into that Raspberry Pi script and change it, right? Change that hard-coded mapping. So that's silly. I should say, I don't know, get the mappings from Kafka, right? So let's collect a little more information. So we're going to expand this this Telegram bot to also collect some mappings of data. Which sensor is mapped to which plant? And so we get a new schema, very simple one, and we're going to store this data in Kafka. So here, literally just two fields here, the sensor ID and which plant it is mapped to. Okay, and we're going to flesh out this Telegram bot to collect this information as well. In this case, so I've added a new conversation. It is going to, here is where the data can be hard-coded because these ones are never changing. Here are the 4 sensor addresses that I can choose from. Select one, don't mess it up, and tell me which plant we're actually mapping it to. Okay, and then I can send that off to Kafka. And now, to make it a little more event-driven, I just need to make this collection script use that mapping, right? This plant has changed, this sensor has changed, update it. And so we need to consume that data from Kafka. And how do we do that? Well, we either use the consumer API or we use Kafka Connect. a lot of the same considerations are going to come into play here as they do for the producer side of things. If you want to react to every event in Kafka, generally you're probably going to use a consumer API, probably, usually. And again, it's flexible, it's available in most of the languages that you want it to be available in, and you're free to do whatever you want with each data point at that point. On the other hand, if you're looking to just sort of bulk move information, maybe take data from Kafka and push it to a database for further analysis, Kafka Connect is going to help you do that. In my case, the consumer API made sense. The first thing I'm going to do is I'm going to look at that collection script, and I'm going to add a Kafka consumer. Okay? And that consumer, its job is, before we start collecting that data from the sensors, we're going to build up a dictionary, build up a map of sensor ID, sensor address, to plant ID. And we need to have a dictionary of 4 values before we can start, right? Because all 4 sensors are going to be hooked up to a plant, and I need to make sure that we have all the information we need before we start grabbing that data. A couple things to keep in mind here, some intermediate configurations. So this underlying mapping topic of sensor ID to plant ID is a compact topic. What does that mean, Kafka? Well, that says, how are we going to clean up that data? You have 2 options. There's the delete cleanup policy, which says when data gets to a certain age, or if we have too much of the data, just get rid of it, right? Like that log file has rolled, get rid of it. The other option is compact, and compact says keep at least 1 value per key, right? So we're going to maintain sort of a long-term mapping, and this is good if you want to use Kafka as a sort of database, right? You want to keep this data long-term or the most recent value, and so that's important here, right? I don't care about what the sensor was mapped to before. I want to know what it is now, and I only care about that now. So you can clean up old values for that key, that's fine. And what this also means is that it's a little more efficient when the consumer starts up. It has less data to actually read through to build up that full mapping of 4 values, okay? Now, Kafka consumers can also keep track of where they left off in the topic, okay? And if I let this consumer keep track of where it's left off, then we run into some issues when, I don't know, the Raspberry Pi restarts, right? Because that consumer has kept track of where it left off all the way at the end of the topic, and when it starts back up, it's not going to read any information, right? It's already processed those events. And so I want to turn that functionality off. I'm going to make this a non-committing consumer. I never want to store a bookmark. Every time it starts up, I want to start at the earliest part of the topic and read up, again, that full 4 value mapping, okay, that I actually need. So to do that, we're going to turn off committing, and we're telling it when it starts up, when it doesn't have a bookmark, start at the beginning of the topic. That's with auto offset reset. Okay? And so now what this means, on startup, this consumer is first going to block the rest of the script. It's going to build up that 4 value mapping of sensor address to plant ID. And then, and only then, is it going to start grabbing the data from the readings and producing it back to Kafka. In the middle of that 30-second loop, it's going to go and try to grab new readings from that, new values from that sensor ID topic, just in case I've moved some sensors around, okay? So now within 30 seconds of me adding new metadata or updating that sensor ID, we're going to see that reflected within this collection script, okay? So that's what it means to be event-driven, okay? All right, so at this point, half the pipeline was complete, right? We have the data flowing into Kafka, the moisture readings are being collected, and it's an event-driven sort of start to this pipeline, right? Now we can start making sense of it. Like, let's process this data. Let's do some stream processing. And you have options. If you haven't actually worked with data in Kafka before to do stream processing, there's a lot of different ways you can go about it. The OG way is using the producer and consumer API. They're really great, again, because they're available in whatever languages you want them to be in. But to use them for stream processing, it's kind of tough. There's a lot of steps in there, right? You have to go through the full process of first consuming that data from a Kafka topic. And if you're doing stateless processing, great. Transform your data and produce it back to Kafka. But what if you want it to be stateful? Are you aggregating data? Yeah, probably. Do you care where it goes when that application goes down? Because it will go down. So that introduces a lot of additional considerations. What do you do with that data? Where are you storing it? Is it living on the machine? Well, what if we lose that, right? Where are you putting that? How are you handling that? How are you making it fault tolerant? Okay. So this involves a little more work, a few more considerations, but if you're doing stateless processing, great. Consumer and producer API is completely fine. But I want to do some stateful processing. Okay, so I'm probably not going to use this. So if you're a sane person and you want to do stream processing, you're going to use one of the next 2 things. Moving up in ease of use is Kafka Streams. Okay? Kafka Streams is a purpose-built Java and Scala library for stream processing. Not a Java person? Too bad. Okay. No, there's some other options available in Python as well if you want to do stream processing, but you're a little limited language-wise in how you set up these applications. But the cool thing about Kafka Streams is that it takes this hassle of managing state off of your hands. Okay? It excels at this, managing this state, not making you worry about it. And so Kafka Streams is built on top of the consumer and producer API. What does that mean? Well, we get that consumer group protocol for free. That ability of these consumers to join together and parallelize the processing of data from a single topic or multiple topics. So what this means is that you can define a Kafka Streams application, define how this data is going to be processed, how this state is going to aggregate that data, how you access it, when you commit that data. And we can spin up multiple instances of that Streams application, and it's going to distribute all of the incoming partitions across those running instances. Okay? And as we build up state over time, not only is that data going to be stored on the local machine, it's also going to be committed back to Kafka. Okay? So we are durably storing that data locally and also committing it back to Kafka. And if any of these applications goes down over time, we're going to rebalance those input partitions to the safe running instances, and we're going to bring that state with it. It's going to read it back from Kafka. So you never have to think about where your state is. Is it safe? Do we have to start from nothing? It is there for you to use. All right? It rebalances accordingly. Way better than the consumer and producer API, and you don't have to think about most of it. And then the easiest way, if you're not a Java person, is to use ksqlDB. So this is a SQL wrapper on top of Kafka Streams. And so you just use simple SQL syntax to define how you work with this data, defining streams, defining tables, specifying how we're actually aggregating and joining this data later on. I'm going to end up using this because it is available within the web browser as part of Confluent. And so I'm lazy. I don't want to be running this anywhere else. I don't want to run any other applications. And we're going to take advantage of this. Cool. So processing with ksqlDB, how do we do it? Well, the first thing we need to do is define our inputs. All right, and there's two sort of first-class citizens in ksqlDB. There are streams and there are tables. So streams represent ongoing series of events where sort of every piece of information is valuable and we want to be able to do something with it. Tables, on the other hand, are kind of like compact topics, right? They represent the current state for a given key. Okay, so let's look at our plant metadata and how we define this. So the plant metadata should be a table, right? They keep track of the most recent value per key, and I'm going to be updating this metadata over time as I learn more about my plants. And I don't want the old values to be used for my stream processing, right? I want the most recent value to be reflected downstream. Okay? So this is a very sort of SQL-esque create table statement. A couple things to keep in mind. So the first thing is that we need to point to the Kafka topic where this data exists, and it's in the Houseplant metadata topic. We also need to specify what the value format is. And we defined those very convenient Avro schemas in the beginning, took an extra 3 seconds out of our life to do that. And there are benefits to that, okay? So you'll notice that, or you might recall, that there are about 10 fields in that schema, but none of them are listed here, right, in that create table statement. So ksqlDB as a consumer looks at this incoming topic, sees the value format, and knows, okay, we're going to go to the schema registry. It looks up the schema for that topic, accesses that schema, and then uses that schema to parse the incoming fields and their types. So I don't have to write any of those down. I'm the typo queen, okay, so I don't have to worry about mistyping anything now. The only thing I do have to specify is which field is going to be the key, right? Because there may not be a defined key on this topic, and we need to know which key to use to maintain the latest value per that key, right? So I can take this statement, I can execute it within the Confluent Cloud Console, or if you're running ksqlDB on your own externally, you just execute this SQL, and this data is going to be propagated into this table for me to access. Okay? So now the readings. Every message in this topic is relevant in this ongoing series of events, so it should be a stream. Okay? I want to be able to do something with each event potentially. So we're going to use a create stream statement that's pretty similar to this create table statement. Again, there are perks of defining an Avro schema, so I don't have to actually specify any of the other fields. For consistency, I am defining an ID similar to the table, so we can do joining easier later on, but you're just pointing to the Kafka topic, you specify the value format, and we execute that. And this stream and the table are going to be available for me to start using. They are inputs into this application. So let's work with them now, right? We need to combine these two data sets, right? The readings aren't useful on their own, the metadata is kind of useless on its own, so let's actually bring them together. This is a wall of text, I'm so sorry. So first thing, let's focus just on the select statement. Standard SQL select, we're doing an inner join on these two data sets, just to make sure that we have all the information we need downstream, just in case. If I took this query, just the select statement, and executed it, I totally could do that, right? And what's going to happen is ksqlDB is going to output everything that's currently in that reading stream, execute the join, and output it on the console. Wonderful. That's not very useful though, because I want to do something with that data later on. So we're going to take this and we're executing a create stream statement, right? Where we're going to pre-populate it with the result of this select statement. So already if I execute the create stream with the select statement, we're going to take the output and put it into that stream. But that's not enough, because it's only going to give me what's currently in the stream. If I want this to be long running, we need to add a little bit at the end, emit changes. So what this says is, as new events flow in on the reading stream, we're going to execute this SQL, append it to this stream, okay, and make it available downstream. This is contrasted with something called a pull query, which is exactly what I described before, where you're pulling a finite result set, just give me what's currently there and move on, right? You use it for sort of one-off checking or just making sure that your SQL looks good. Now we can act on this data, finally. Finally. Right? We have all the information we need in that stream, right? In our Houseplant readings enrich stream, so we can start doing something with it. And I want to revisit the overall goal here, right? I want to be able to alert on these plants when they need to be watered, right? So whenever a single plant has enough low moisture readings, as per its low moisture threshold, I want to send an alert. Now I've changed this value a couple times since I've started. Originally I was capturing data at like 5-second intervals just for fun. Why not collect all the data and store it in Kafka? But right now we're collecting the data every 30 seconds. And if I alert it every 30 seconds, well, that's really annoying. That's really annoying. It's useful to collect this data so I can see trends of my plant's watering needs over time, but I don't need to alert every 30 seconds. That's ridiculous. And so I figure if I'm out of the house, if I'm across the world at a conference, it's probably more reasonable if I alert maybe once every 6 hours, right? That gives me enough time to tell the person who's taking care of my plants, okay, water them the next time you're there, right? Do something. So 6 hours seemed good. I also noticed that these sensors weren't perfect. Okay, for those of you who have worked with hardware stuff, you know. The $1 sensor is never the best sensor, right? It's convenient, but it's never the best one. And so after I weeded out the sensors that were clearly broken and actually used the ones that were good, there's still some false low and false high readings over time, right? Just randomly you'll get like a 99% moisture reading, you're like, well, it was 12, so that's weird. But the general trend over time is obviously that the plant is drying out. Okay, so it is a decreasing trend, and that's good. So within a 6 hour period, it's not guaranteed that we're all going to get low readings the whole time, right? But it's probably good enough if within that 6 hour period, if I received 1 hour worth of low readings, that's probably serious, right? That's good enough. I should probably water that plant, right? And so 1 hour's worth of readings, if we're taking readings every 30 seconds, do the math, it is 120 readings within that 6 hour period before we alert for that plant. Okay, and those 120 low readings can be anywhere within there. That's totally fine. We're going to trigger an alert. So this is the query that is going to do what we just talked about. So let's focus on a couple key details. The first thing is that I want to alert at most once per plant in a 6 hour period. So the first thing that we're going to do is we're going to use windowing. Okay, I'm going to set this up to aggregate over 6 hour non-overlapping windows. I have a grace period in there as well, just for late arriving events if we need to. So already when an event flows in, we're going to bucket it into this 6 hour window that it belongs in. Okay. Now from there, we want to count the events where the moisture reading is lower than the low moisture threshold, as outlined by that metadata. Okay. Whenever I get at least 120 readings within that window, cool, send an alert. And also, we're grouping by plant ID, if that wasn't clear. All right, that's awesome. I don't want to oversimplify this because when you look at SQL for stream processing, it's easy to kind of ignore the fact that this is actually a streaming application. There is state in there, and we are reacting to every event as it comes in, potentially. Okay, so I want to clarify a couple things. First of all, when we are windowing and conducting some sort of aggregate in ksql, the output's going to be a table, okay? Because we are aggregating, so whenever an event flows in, we can potentially output something, right? And the next time an event flows in, we can output something. And we're going to update that value per that window, per that key, all right? So tables maintain the latest value per key, and so that's exactly what we're doing. We might have multiple rows output per key, but only the latest one is really the most relevant one, useful one. So we have a table. So as each of these records are processed, we're gonna bucket into that appropriate window, we're determining its key, and we could potentially access the state according to that window, according to that plant, that key, okay? And we are updating that underlying state. I mean, it's just a counter in this case, but you can do more interesting aggregations as well. But every reading that breaches the threshold, we're going to update that state, and that's going to be counted towards those 120 readings. You might be asking yourself, what happens when we get to the 121st reading, 122nd, 123rd? Am I still facing that same issue of getting one alert every 30 seconds? That would kind of suck, right? So the answer is no. We have a little bit here called emit final. So what this means is we're going to wait until that window closes before we assess and output an event. Okay. So this is against the opposite of emit changes. We're just going to wait instead of emitting absolutely everything. We're going to wait and emit at most ones. So that's great. I now had a Kafka topic containing messages every time a plant needs to be watered. All I had to do now was get this data out of Kafka. This is pretty easy. Let's see how to do this with Telegram. I wanted to receive this on my phone. How do we get this data out of Kafka? Well, I could just set up a producer or a consumer, right? Consume from that topic and then push that data to my phone somehow. We already saw how Telegram can be used to define a conversation, right? But we can also use the Telegram API to use that API key that was given to me, access all the conversations or see the conversation IDs that I'm having with that Telegram bot. And using that API key, using that conversation ID, I can build up an endpoint that I can then send the data to. That's really convenient. What do we do with an endpoint? Well, we have a Kafka Connect HTTP sync connector, all right? So you can configure this, you point to an endpoint, you tell it which Kafka topic to consume that data from, and every time a new event flows into that topic, we're going to push it to that endpoint. Okay. There are some capabilities in there for batching if you want to send multiple pieces of data at once. There's regex in there as well if you want to extract certain fields, which is what I'm going to do here. But entirely configuration-based, I set that up. I start it up on Confluent Cloud. It's running. And then every time a new event flows through, this is what I see on my phone. Right? It guilts me into watering my poor plant. All right. So just as I know we have only a couple minutes left, but I'm pretty proud of this project. It's my first hardware project. It actually works, right? And I got to use Kafka. That was amazing. And this is for a very real use case that I care about. When I first set this up, and even now, I don't touch those 4 plants until I get an alert, right? I completely rely on that. And even the plants that aren't hooked up, I don't really care about them either until I get an alert as well. So I really hook the neediest plants up to this sensor system and take care of them. So. Okay, so you followed along, great. You saw an interesting project, but what do you get out of this? Okay, this is very transactional. I want to make sure you get something out of this, and you did. I tricked you, okay? This is a streaming data pipeline, right? The generic version. This is what we built today. If you squint, they're basically the same thing. Okay, hear me out. We saw the different ways that you can get data into Kafka. You saw how to use a Kafka producer, the different options that you have, and also how you can use maybe Kafka Connect as well. We were introduced to stream processing, the different ways that you can do this with the consumer and producer API, Kafka Streams, and more specifically with ksqlDB. And you saw a little bit about how to get data out of Kafka. We inserted a consumer in that Raspberry Pi script, and we also used Kafka Connect to push that data to a downstream system. Every streaming data pipeline you build is going to have some combination of those 3 things. And you don't know what you don't know, so now you at least know those tools that you can use to build your own streaming data pipeline at some point. And I hope you will, right? If you haven't used Kafka, or if you haven't yet made the jump to use Kafka at home for a ridiculous use case, I would encourage you to do so. And so if you are curious and you want to use Kafka at home or build something cool like this, I have my link tree up here. In there, I have a link to the source code if you want to take a look at that, and also some additional resources on our Confluent developer portal. On there, we have like a dozen or so free courses to walk you through intro Kafka, intro ksqlDB, stream processing with Kafka streams, and more. We get into intense things like Kafka internals as well, so check it out if you're curious about learning more about Kafka. And I also have another session at 11:30. We're going to dive into Kafka producer internals, so if you're curious to learn more, check it out later. And I will leave that up, but I can take some questions now if anybody has some. Thank you.